Sure.
Okay, so this is our second section. So regarding the AWS account creation and the credit card, I will share my screen.
Does your computer get slow from having so much on the desktop?
No. It's small size files actually. Most files are related to nodes, some PDF like that.
Is the profile picture you have from where is that located? Leh?
Which profile picture?
You have like on your WhatsApp profile picture, it has some binoculars looking at a lake.
Yes. I
It's a
think,
nice picture.
yeah, I got from, I think, I don't know actually. It's
I was going to go to the store and get like a prepaid card that only has certain amount of money. So I put that on there.
yeah, we will go through that. Okay. Before that, I will share my screen. My screen is visible, right?
Yeah.
Okay.
It keeps changing its size, but
Yes, I'm changing the accurate size, but okay. Then we go into the section. So, coming to AWS, okay, we will take the AWS account first to go through the website. I think you already go through that, right? You already created website.
yeah, I created the only thing maybe I should have put business instead of personal. I put personal there.
Yes, personal.
But either
Then
way, it's
give
asking
the
for
give the basic details. Then there is a payment option. So use the debit card. Then go through that. Okay, this is a free tier account actually for 1 year, and the 1 year means basically it's a free tier. Okay, free tier for 1 year. But some limitations are there. Okay, I mean the limitations are I think around 750 hours of compute power. Okay, I mean uh, compute. This means we can run virtual machines, and the time duration of the virtual machine is 750 hours. This is, I think, this is for the 1 year. If we exceed this duration, they will charge actually. Even we are in the free tier. Got it? The same
right.
way, each services there are some limitation. After exceeding the limitation, they will charge. Got it.
Yeah,
So
there is one article there that says how to avoid the charges. So you have to be careful the way you use it, I think.
yeah, for how to avoid means we need to ensure that, for example, we have 750 hours of virtual machine running. Okay, so each section we start the mission. I mean, we configure the mission, we set up the lab. After each lab, we need to terminate the entire
Instance.
thing that we already created.
Yeah.
Yeah. So this is a mandatory thing. Otherwise, it will charge
Yeah.
in dollars or like that. Okay. Got it.
Yeah.
So today we will cover the DevOps principles, the concept, the adaptation, benefits of DevOps, what are things we done before DevOps, all the things we will cover today. Okay. This is
Yeah.
purely theory section. I think from the next section, we are starting the cloud basics along with the labs. Okay. The question, you have any idea what is DevOps and the DevOps culture? Hello?
I'm thinking of the answer to give.
Okay.
I think as more and more computers became available on the network through a web interface, this became possible. So probably um, initially people had computers on their site that they used,
Okay.
and then somebody set up a big infrastructure and started marketing it as a cloud, and then it
Hmm.
became a thing that you're going to just use a machine somewhere else.
Okay.
How the phrase evolved, I'm not sure, but a lot of thing in the IT industry, the phrases evolve over time. People accept them.
Okay. Is it a job role? I mean, the DevOps.
Yes, I think before it was called DevOps, it'd probably be like a system administrator that deployed things, right? People wrote code and the system administrator put it into production. No?
Yeah, most probably. System administrator. Okay. So
It's a new
Basically,
version of the system administrator.
yes, we can call it as like that, but some changes there. Okay. Actually, DevOps is not a role. Actually, got it. It's not a job role or any job post. It's actually a life cycle. Or we can call it as a culture. Got it.
Yeah.
We called as DevOps engineering. Okay. So we can quickly jump into what are things we are following before the DevOps. So you will get more idea. So before DevOps, okay, we are taking the example. Okay, the example is software development. Software development. Okay, so some people are planning to create some software. Okay, we can take an example like WhatsApp. They are creating WhatsApp. That's a software. So you know the life cycle. I mean the step-by-step process of how the software development, how the software will be delivered in between so many things there, right? Any idea?
Every time you write some code, you have to test it before you
Mhm.
put it into production. So there's probably also like regression testing to make sure you didn't introduce new errors. And once all that testing is done, it's accepted, then it is merged into the new branch and released.
Yep. Okay.
So it's like a DevOps is a support role, right? Like a support role.
Supporting for so efficient software delivery. We can call us like that.
Yeah, yeah,
It's not a purely support actually. We are
yeah.
the core
It's not tech
infrastructure.
support. It's like um, it's not tech support. It's more like a get it to production kind of a
Right, right,
support.
right. We are the one who take the codes from the development part and build the code, test the code, all the things. Then after we deliver it to the production part. So this is the previous scenario. Okay, I mean, mm, this is a scenario before DevOps. I mean, a traditional way. Traditional way of deployment. Okay. So the thing is, some developers are here. Okay, this is a first phase of the software. So this is the first phase. Here there is a lot of developers. Okay, I mean 5 or 6 or 7, five developers are here. They will write up the entire code for the WhatsApp application. So they will write all the codes. Then the scenario is they have their own PC. Okay, each individual PC is there, and they will take some modules. Okay, for example, this is the entire WhatsApp application have thousands of code. Then each developers will take, I mean, divide the codes. Okay,
Clone
like
it.
modules
Clone
200
it.
or 200 like that. Then they will merging all the codes and run it on their own devices. Okay, then they will get the success. The application is running on their own device. So this is a phase. This phase called dev or development. The next phase is after completion of the successful application is running, then this application needs to deploy to the production server for accessing the end users. Because whenever we are open the Play Store or Google, downloading the WhatsApp, right? That's where the end user accessing the application. Downloading the application because the application is live, right? So the next phase is operation. This is the operation phase. And here we already discussed about the system administrator, right? So the under the operation, there is a lot of system administrators or the IT engineers. All IT, infra guys are under the operation part. Okay. The one who under the operation teams means these types of engineers, like managing the infrastructure. The servers, storage, database, all guys are in under the operation part. And the dev part is purely developers. Okay. So here they successfully run the application. Okay. In their own machines, they will get the success. The application is running successful. Then they will send the enter code to the operation team for deploying their application. So they will send the enter code to the operation team. So the operation team have their own PC, okay, for the testing purpose of the same application. So the enter code coming to that operation part, sometimes it may face some error, okay, some bug issues or some dependency issues. This application needs some prerequisites, right? For example, I have one PC, you have one PC, okay. We the both, these PCs have different libraries, dependencies, framework. So we need to ensure that the same prerequisites are in same, different PC to run the application. So the scenario
The
is,
requirement has to be exactly the same.
yep.
Like same operating system, same version of everything.
Yes, the
Same tool.
prerequisites there. All the things are there. Otherwise, it will make some messy things like the application crash, bug issues, application does not run correctly. So many related issues are there. Okay, the codes coming to the operation part. These are the PCs. Okay, consider these are the PCs, and this is the IT case. So whenever they will run the application here, this may be fail. Most time, if the application success, they will send it to the production server. Okay, this is a production server. So the end user can access the application because the application is live, like that. So whenever whenever the application code is fail here, they will ask back to the developer that this application is not running in our PC. Kindly check the things or like that. Here, this is, the dev part and the operation part, there is no a direct connection. Okay. There is no a bridge. Got it. They will, in real scenario, like they will send the uh, enter code to the team. Okay. This here, there is lot of miscommunication because this will take time, right? They will send the code first. They will send the code, and we are running the application successfully. Try to push the application to the production. So the IT guys run the application. They will facing some error. They will send back the code to the development team. Then the development team again check the application. Then after clear the things, then they will again send it to the IT person. Then this cycle is repeating. Okay, whenever the successor here the application success, they will push the code to the production. Otherwise, this process is repeating, like sending back and sending uh, again. Correcting the code, then send to the production team. So here the one of the main problem is miscommunication. There is no a proper communication between this dev and operation. So due to miscommunication, something happen like time. Time is one of the most important thing in software development. So this, if the time is delayed, what will happen? The cost, right? Because
Okay.
here the client requirement is please complete the application within 2 weeks or 1 month. So here these problems makes this lags, right? It will take more than 1 month or 2 months. So the cost and time, all the things are related to facing some issues, right? So
Life
these
is
are,
made up of time, so time is valuable.
yes, yes. So these are the main issues we are facing in traditional software delivery or software deployment development. Okay, so here the new life cycle plays a good role. I mean, that's called DevOps. Got it. This is a culture of software development. Okay, so I will show you how the new culture change the role. I mean, change the entire scenario. So, okay. Again, we are going to deploy the same, I mean, creating the same application WhatsApp. Okay. So we are going to create WhatsApp. Okay. This is our software we need to development. Okay. So we are developing WhatsApp. So here we are using the new methodology. I mean, new life cycle that is called DevOps. So coming to DevOps, the same scenario. Okay. Like the developers are here. There is 3 developers. Okay, this is a development phase. So here they will write up the code. Okay, write up the code and they run the code. I mean, locally they will run. Okay, they're on PC. They will run the code, and after successful, they will push the code to a center repository. Okay, same thing in before they have their own repository there. Consider this a GitHub. Okay. So what will you here? The developer will write the code and push the code to the GitHub repository. In GitHub, there is a main folder there. Okay, like there is a folder called WhatsApp. So inside the folder, they will push the code. Okay. So this is dev part. So from here to production, there is the operation part. Okay. So here the production part, and this is the infra, and this is called, this is the DevOps culture. Okay, DevOps. So coming to DevOps, we are integrating some new features called CI/CD, continuous integration and continuous deployment. Did you heard about CI/CD?
Yeah, you mentioned yesterday.
Yes.
You basically continuously integrate the code and you continuously develop it.
Right,
You
right, right.
continuously test it.
Uh, I mean, in traditional, there is, we discussed the miscommunication, right?
Yeah.
So coming to DevOps, uh, the CI/CD, I mean the continuous integration and continuous deployment. We can, I mean, consider these two things. Okay, one is miscommunication, and here coming to DevOps, we are continuously monitoring or continuously integrating thing and continuously delivery or deployment the codes. Got it? It's confused, right? Yeah, I will quickly. So coming to DevOps, we are using some CI/CD tools. Okay.
Okay.
One of the common CI/CD tool in the market is Jenkins. It's an open source tool, Jenkins. We will go through the Jenkins, okay, in deep dive. This is just for the demonstration. So what will the infra guy or the DevOps guy will do is he will configuring and managing the Jenkins, okay. I mean, we are installing the Jenkins in a server. Then we need to connect with this GitHub repository. Got it.
Yeah.
Then we connect Jenkins to the live server. This is a live server. This is a machine. Okay, consider this is a machine. So what will happen here? Whenever the developer will push the code to the GitHub, the Jenkins will automatically getting the code from the GitHub to the Jenkins. Then here Jenkins will test the code, build the code, and deploy the code to production machine. Got it?
Not clear what Jenkins does exactly. So Jenkins, I will do testing automatically, but who writes the test? Maven, the tests are written in Maven or something?
Maven is a build tool for Java related application. For example, if we are using Java application here, the developers wrote up the Java, then we can building this Java using Maven. So we can integrate in Maven here. As per the requirement, we need to indicate so many tools here. Okay, this is a simple workflow. Just to know the workflow, you can easily find out the thing. So yeah, you can leave the Maven right now. Okay.
Okay.
Yeah, Maven is for Java related application. I mean jar related application.
When you say build, it means you linked all the object files and made a executable, right?
Yes. I mean
That's what the
the raw data. I mean raw here the developers will store raw codes, right? I mean n number of code or 1,000 numbers code like that. So we need to compile the code and run the code, build the code, wrap up the code, all the things inside the Jenkins actually. So we need to provide the all information. Okay. I mean, Jenkins does not know how to do the things. We are the one who need to tells to the Jenkins what are things you will do that using the Groovy. I mean, some languages are there in Jenkins. Okay. So the Jenkins will do whatever we are provide to the Jenkins. And coming to this is a workflow. Okay. I mean, this is a high level DevOps workflow. So DevOps is considered as a looping system actually. This is the way. Okay. Inside the loop, we called as we are testing, building, planning, then monitoring, all the things happening in the loop actually. Got it. For example, if anything is failed, we run the same thing inside the loop actually. So okay. So here we are using a our application is running in live production. Okay. This is a WhatsApp are in the live server. So the user can access the machine and download the WhatsApp. Consider like that. Okay. So there is now our application is live. So after 1 or 2 months, we need to add some features in WhatsApp. Okay. I mean, we need to add the status features or story features or anything like that. So what will you do? Any idea?
We will create a branch inside GitHub, Git to work on that new features, and then we'll test that branch and see if that branch works nicely. Then we can merge it into the main code.
Yes. Yeah, that's fine.
But I think I'm not clear how, like Jenkins, maybe there's a lot of automated tests stored in there, or it automatically builds the code and tests it.
Yes. So
But it directly interacts with GitHub. So it directly goes to, like, you install Jenkins on your Linux server and it will
yep.
do that. Okay.
Yes. So yeah, that's a way. Okay. I mean, there is a WhatsApp main branch here. WhatsApp is a main branch. So the developers will take a branch. Okay. This one make another branch, and the third one. Each of the developers will take on each branch. Okay, and they will add the new feature. Then they will merge back to the main branch. Okay. If whenever, I mean, when they add the new features, then they will run the application locally, okay, in their own machine. At the time they will face any error, they will easily roll back. Okay, that's one of the major benefit of these types of VCS, version control systems.
Yeah.
We can go back like a time travel mission. Okay, we can jump back to the previous stage like that, easily roll back.
Just check out the older working version, basically.
Right. So, okay, this is the purely development part. Okay. So after they will run successfully new feature, they will merge, merge into the main branch and commit the code. Okay. So whenever new changes in the existing code in GitHub, Jenkins will know there is something, some changes are in the repository, the WhatsApp repository. So Jenkins will automatically getting the code from Jenkins, the GitHub to the Jenkins, and do the same process that before done. Okay, testing again, it will testing and building and then deploy. So this is the integration part, continuous integration, and this is continuous delivery. Sorry, continuous deployment. So the Jenkins will automatically do the things. As a infra or DevOps guy, we didn't bother about that thing. The newly features. The second phase. Okay. The second version, the developer will write up the entire thing and commit to the GitHub. So the Jenkins will do all the things. We didn't bother about anything. If there is any issue there, then we need to go and dig. For example, the Jenkins will integrate the CA part. Okay, CA is done, but CD is not properly running. So we need to go to the Jenkins and what happened to this thing and like that. Got it. This is a simple DevOps pipeline actually. Coming to, a corporate pipeline, a real world scenario, we integrate so many tools with Jenkins like Docker Hub, SonarQube for code analyzing, Maven, OWSP for checking the code quality, dependency checking, all the things. So many tools we are integrating. Got it.
Yeah.
Any doubts?
I have my own Linux machine, so I think it'd be interesting for me to install like Jenkins and everything on there and like just work on it directly instead of getting something ready-made from a cloud. Might be a good exercise for me.
You have Linux machine, right? Ubuntu.
Yeah, I have Ubuntu. I can install any Linux needed, but
okay.
Ubuntu is good because it has a good GUI, so you can cheat a little bit.
Yeah, we are mostly work with Ubuntu actually. Whenever we are installing, configuring Jenkins or related things, Docker, Kubernetes, all things we using Ubuntu most probably.
Yeah, I have two two Windows machines from Dell that I basically created a partition and added Linux on. So one of them I made it again fully Windows for some project, but now that project is over, so I can basically just take that machine again. I have a more memory and more SSD in it, so I'll my put Linux on that again.
I mean, my consideration is we can concentrate on cloud actually. Okay, you can easily spin up the machine and run this in labs. But one thing for your local machine, I mean local Ubuntu machine, you install the Docker actually. Okay. Not now. I mean, whenever we are cover the Docker part, you can install the Docker and you can test Docker application, write up the Docker image and all the things. Okay. For Docker, it's easy. I mean, it's better whenever we are using the local Ubuntu machine. Same for the Kubernetes. Okay. You can set up self-hosted Kubernetes cluster in your local machine. Kubernetes. Because these tools are the main things in DevOps actually. Dig more into Docker and Kubernetes. These are the two types of, I mean, like kings in DevOps.
What are the kings of DevOps?
Yeah, these two newly infrastructure. This is actually a kind of infrastructure. And yeah, coming to the CI/CD tool, we concentrate on Jenkins actually. So we will cover the Jenkins. And then coming to monitoring part, we go with the Prometheus, Grafana. Prometheus and Grafana. And automation, Terraform. And
what does Prometheus and Grafana do? I forgot this. What they do? Prometheus and Grafana, what do they do?
Prometheus is a service actually. Prometheus is, for example, this is a machine, okay? This is a server. This server have lot of resources like CPU, memory. Memory means RAM, okay? RAM, then applications, apps. Okay, so here we have one more application or called Grafana. Grafana is a web application, okay, for, I mean, monitoring purpose. We are using Grafana for monitoring purpose. So Grafana needs monitoring means visualization, okay, visualization of our infrastructure resources. For example, we need to monitor the CPU of this machine using Grafana. So the Grafana needs some logs and metrics of these machines. Got it? I mean the CPU's logs or metrics. We need the metrics of this machine CPU. So this will taken by the Prometheus. Prometheus is actually it's a kind of agent, okay? That agent will collect the logs and metrics from this machine, and we need to integrate this Prometheus with this Grafana. Here there is configuration part there. So under the configuration part, we need to choose the choose our point. I mean, there is a point that is called a Prometheus data source. Here there is a option called data source. There is a lot of data source there, like Loki, Prometheus, so many lot data source there. So in this scenario, we choose the data source as Prometheus. So already Prometheus collect this PC's details in the Prometheus dashboard. So here we connect with the Prometheus, and the Prometheus will send all the logs and metrics to Grafana. So the Grafana here that we can create the dashboard. So dashboard for the CPU, the memory, application, all the things, and we can visualize. I mean, the Grafana visualize all the things. I mean, we are going to the lab. You will get more idea about all the things, like what are things Prometheus do, Grafana do, all the things. Got it.
Yeah, yeah. You have to slowly take in everything, so it
Yeah.
becomes part of your reflexes.
Yes, yes.
So when you go into the AWS, you get a Linux instance running. You will have to install all these things on there.
Yes, I mean, whenever we are in each section, do from the scratch. Okay. I mean, creating machine, installing thing like that.
Right.
So you will get more idea
How
about.
powerful the machine you need? How much memory and hard disk space? How do you need?
That's as per our each lab. For example, some labs we need to install different application, consider different application. So as per the application prerequisite, we need to choose the RAM size, memory size, all the things.
I see.
Otherwise, mostly we are going with the default free machines. I mean, we are using the free tier, right? So under the free tier, there is some free tier machines there. So most probably we are using the free tier machines.
Okay.
Got it.
Yeah, yeah.
Any doubt?
No, I think I'll just need some more time to digest Prometheus and Grafana. But
Yeah.
Prometheus monitoring the resources,
Yes,
and
yes.
Grafana is monitoring data.
These are purely under the observability parts, okay? I mean, observing our infrastructure. Using these tools like Prometheus, Grafana. These two tools are open source. That's why we are using this. Similar other application there, paid application like Datadog, Dynatrace, so many observability tools are there. Coming to DevOps, we are using mostly these two tools.
The open source ones.
Yes.
Open source has slowly, steadily become bigger than the closed source softwares.
Yes, yes.
Okay, go ahead. Go ahead. I got it.
Yep. So coming to principle, concept, culture, collaboration of DevOps, we can introduce the DevOps engineering actually. Okay, like DevOps is a set of practices that combines software development. I mean, that the dev part, okay, and the information technology operations. That is operation piece, where the IT guys, system administrator, cloud engineers, all persons are under the information technology operations. That is operation. So the collaboration of these two, I mean the dev and the operation is called DevOps. Got it?
Right.
Before DevOps, there is miscommunication there, so many things there, okay? And I mean the combination of these two things, I mean the dev and the operation, we are aiming to shorten the system development lifecycle and delivery high quality software continuously. Got it?
Yeah.
We need to underline that word continuously because the using CI/CD tool, we can say this called continuously because this is continuously integrated and continuously deliver our deployment. So some key objectives are automation. Okay, we can automate all things like streamlining and automating the software delivery process using automation tools like Terraform or Ansible, CloudFormation. There is a lot of automation tools there. Then collaboration and communication between development and operation team is enriched using the DevOps culture, I mean, DevOps principle. We can easily communicate with the development team like that. That's a scenario actually. Same way, coming to the continuous.
You described like they send the code and they you send the code back, but usually it just like probably sits on the same repository. You just send a message that, oh, the test failed, fix these bugs, right? That's how it will happen.
Yes, I will.
The code physically doesn't move. It just it's checkout version
Before,
such and such.
yes. Before, I mean, coming to traditional, this is dev and this is operation. Okay, there is no
Right.
communication or bridge between these two different teams. Coming to DevOps, we are using CI/CD tool. Okay, for example, this is a developers, and this is the repository. I mean, GitHub. They push the code to the GitHub. Here we are using the CI/CD tool. Okay, so the CI/CD tool will mostly done most of the operation jobs like testing, building, all the things. Whenever they are facing, I mean, inside the Jenkins, this is Jenkins, okay? I mean, CI tool. This is the first part, continuous integration tool. Here the CD tool, okay? We just leave the thing. Now we are in the CI part. So whenever new changes or they will create some new projects, okay? Consider like that. This is newly project. So we integrate that GitHub. This is a GitHub. This is a Jenkins. So we integrate GitHub with the Jenkins, okay? And run the job. Here in Jenkins, we need to create a job. I mean, this job for this application like that. So inside creating job, and we need to provide so many information. What are things we need to do with Jenkins for the application that is in the GitHub, okay? So all the things we provide and create the job and run the job. Whenever we run the job, the Jenkins will getting the code from the GitHub, okay? And here it will test the code, build the code, and later things done. Whenever, I mean, any phase it will face any error or anything, the Jenkins will automatically send the feedback to the developer or us. Both they send the developer as well the infra guy. So we are going to dig to the issues, and same way the developer will get the feedback. They will rewrite the thing and push the thing again. Then Jenkins will do the same thing in cyclic way like that. Got it?
Yeah.
This is called a feedbacking. Okay. Whenever same way, if success or fail, we will get a feedback at the same time. And mostly inside the feedback, the Jenkins specify the error or what are the issues are facing like that. So easily they will find out the thing and clear the thing.
Right.
Got it. Yeah, that's under the continuous improvement. Okay, encouraging a culture of continuous feedback and improvement. So coming to principles of DevOps, this is a practice of merging code changes frequently. Okay, I mean the CA part. It's a practice of merging code changes frequently, ensuring that a build is always in a deployable state. Coming to continuous delivery, extending CI principle to automatically deliver changes to production, making the software always ready for release. Then coming to another principle is infrastructure as a code. That is IAC. We already discussed that Terraform and a lot of IAC tools there. And using IAC tools, we can automate all the infrastructure. Okay. And IAC tool is actually treating infrastructure configuration as a code. We wrote up all the infrastructure as a code. Okay, we didn't go to manually set up all the infrastructure. Okay, we already wrote up all the infrastructure in a code, and we push the code to the corresponding cloud provider like AWS or Azure. So the Terraform tool will, or the automating tool will create all the infrastructure.
The
Coming to
AWS has some scripts to do that, right? Like the
cloud
scripts
formation.
create this many machines with such and such configuration. So it's more accurate than doing manually so many machines.
Each cloud providers have their own infrastructure as a code tool. That is
Okay.
coming to AWS, the name is cloud formation.
Cloud formation.
Yeah. Coming to Azure, there is ARM, Azure Resource Management. But yeah. So each providers have their own automation tool, but most probably as a DevOps guy, we are choosing like Terraform. I mean third party automation tools. That is common. Commonly, we are using automation tool like Terraform or Ansible because these using, for example, I am choosing Terraform instead of AWS CloudFormation. Okay, so whenever I am choosing Terraform, so using Terraform, I can deploy application to AWS, Azure, then GCP. We can choose the corresponding provider. Okay, so that's one of the major benefit why we are choosing Terraform. Got it. Or some guys are only concentrated on AWS and he or not concentrated on other cloud provider or any other tools. Then the guy we can choose the cloud formation or anything like that. I mean related to the cloud provider. But the best practice is concentrating on a single common tool like Terraform. Got it.
Yeah. Have you heard of this company called Linode?
Linode is a cloud provider, right?
Yeah, it's close by to me in Philadelphia.
Yeah. I mean the company, right?
Yes.
Yes. Linode is a cloud provider actually.
Yeah. It stands for Linux Node.
Yes. I go through that. I mean the website. You can easily spin up machines and all things there. But purely for some, we can for example, quickly we can install machines, servers, containers, Kubernetes, that kind of thing we can choose Linode. There is no other services are there, right? I mean, coming to AWS or any other provider, there's a lot of services there.
Right.
Yeah.
But maybe
Then
Linode is cheaper for a smaller startup. It might be cheaper.
yes.
If you are ready to do more work, then it will be cheaper, right? So,
Yes.
but sometimes it's better for you to spend the money. If you're a big company, you can spend the money on AWS and get the results faster because getting your business going is worth more money than spending time getting it ready. So it decides on the business decision.
Business,
The client.
yeah. All things are related to the business needs actually.
Yes. Whole life is like that.
Coming to corporate application or corporate, mostly using big size providers like AWS or Azure. Coming to my company, we are using Azure platform.
Okay.
Yeah.
Which company you work for?
I'm working USD Global.
USD Global.
Yeah.
Are you on LinkedIn?
Yes.
I will send you an invite.
Yeah,
My
sure.
name is Amol Apte from Green Futures.
Okay. I will search.
How do you spell your last name?
Yes, stand for Shah Jahan.
S.
Yes.
Toufeek.
No,
Right?
I will. This is the name.
Taufik.
Yeah.
Taufik S or just
Yes,
S.
yes, yes.
I'll send you a LinkedIn invite.
Yeah. And coming to the principles, one more thing is monitoring and logging. That is, we already discussed that Prometheus Grafana. Implementing robust monitoring and logging practice to identify and addressing issues proactively. That's why we are using these observability tools. Okay. Then some concepts are there. I mean, concepts in DevOps engineering. One of the main thing is microservice architecture. I mean, designing application as a collection of small independent services and enabling scalability and flexibility. And coming to microservices, we are using containers and orchestrations. Okay, like Docker, Kubernetes, all the things under the containers and orchestration. Using containerization, we are using Docker. Then orchestration, we are using Kubernetes. These tools are for consistent deployment and scalability actually of application. Then version control, managing and tracking changes to source code using version control system like Git or GitHub. We are go through the Git actually. Mm, Git merge, Git pull, all the things we will cover in our course. Then collaboration tools, utilization of collaboration tool like Slack, Jira, and Confluence to enhance communication and coordination. These are service management tools like Jira. Did you work on Jira?
No, I didn't work on Jira. I only knew some Git commands basically to merge and check out.
Yep. Okay.
And you can write tests for your code.
Jira is actually service management tool actually. When we are working with corporate management, okay, we are go with the ticketing tools. Got it. Jira is one of the ticketing tool. So whenever someone face some issues, they will create a ticket and mention what are the things they are facing and send it to the concerned team to work on that. So I am the person who need to work. So I need to assign the ticket to me. Then I will work on the issues and I will update the step-by-step process or what are things I am going through. All the things I mentioned in the ticket and close the ticket.
Right.
Yeah. Then coming to culture. Sorry.
Very important to move quickly and resolve tickets.
Yes. That's as per the priority actually. So for example, in my company, there is 10 people, 10 engineers are there. So only one engineer is facing some issue with some application or anything. I mean, some production application or anything. So that issues may be a medium issues or below medium. And coming to the ender engineers are facing the same issue, then it is called a high issues like P1 issue or P2 issue like that. So whenever we creating the ticket, we need to mention the priority as well. So as per the priority, the concerned engineer will assign the ticket and clear the issues as soon as possible. Yeah. Then coming to DevOps culture, we already discussed that's a collaboration and communication. The important is breaking down the some silos and silos and fostering of open communication between development, operation, and other stakeholders. And this is a shared responsibility actually. Everyone involved in the development process and share responsibility for the software success and reliability. Then continuous learning is another thing we need to, encouraging a culture of continuous learning and improvement. Because some new features or some new requirement there, we need to learn actually. What is the difference between a cloud engineer and a DevOps engineer? Any idea?
Cloud engineer is like a network engineer. It sets up a network of
No,
computers.
no,
Sorry, no. Cloud is kind of a made-up word.
no. I mean, coming section, I mean, the next section we will start with cloud actually. So don't worry about that. We discuss about the system engineer, system administrator, right? System engineer or admin. Okay. In traditional way, this is a company, okay, a corporate company. So inside the this is a traditional way, okay. This company have their own IT infrastructure there. This is a server room. Inside the server room, this is office, some office. This is account section, okay, consider like that. And this is a development team or anything. So this is a server room, okay. So inside the server room, we keep the server, switches, firewall, all the things are here. So someone needs to manage the entire IT infrastructure of this organization. So we need to hire system engineers or system administrator to manage these type of IT related infrastructure, right? So they will manage the entire IT things. For example, if any issues there, for example, printer issues there or server issues, or someone doesn't have access the internet. So many related issues are inside the organization. So the IT administrator will clear the things. So coming to cloud, okay. Coming to cloud, this is considered, this is the AWS platform, AWS. So the corporates are nowadays moving, I mean, transition from the on-premise to cloud, right? For the high scalability and availability of resources. I mean, mostly corporates are moving to cloud providers. I mean, cloud computing. So coming to cloud, the same thing we need to create. I mean, the IT server room. So virtually we creating all things in cloud, right? I mean, here there is a local network there. I mean, network there in this scenario. I mean, the physical scenario. So coming to cloud, we need to create the same thing. I mean, we need to create the network, subnet, and here we in this scenario. I mean, the previous scenario, we need to. There is lot. I mean, 50 employees are there. Okay, we need to buy 50 physical PC for each person. Okay, so coming to cloud, we need to do the same thing. I mean, we need to spin up 50 virtual machines there for working these peoples. So we need to do the entire things in coming to cloud provider. Okay. So here someone needs to manage the infra, right? So the name is cloud engineer. So the cloud engineer will manage all the things. I mean, basically, the system engineer will be the same kind of cloud engineer. Actually, they will acquire new skills. Okay, I mean the new technology. They will learn cloud computing skills and all the things, administration. As a cloud engineer, they will, I mean, the person will manage the cloud resources, administrating cloud resources, and like that. These are the core jobs of the cloud engineer. And
Instead
coming,
of having the physical possession of the machines, these machines are located in Amazon's data center or some other
yes,
big
yes,
company's data
yes,
center.
some
But
that
the
is
same commands and everything, operating systems, configuration, those same things you will have to do. Only thing is you can just order it through your website, like the console will say, oh, give me such and such Linux machine with such and such ability, instead of having to buy it yourself and install it yourself and run it yourself, right?
yes, yes, most
So that's the
probably.
difference between a system engineer and a cloud engineer.
Yes, yes, yes. Mostly they are doing the same role, but one is in the physically they can access the machine, all the things. One is virtually do the things.
Right.
Yeah, with the
I
new
mean, the
technology.
system engineer, the AWS will hire to work inside their data center.
Yes. And the difference between a cloud engineer and a DevOps engineer is, you can quickly say a, a cloud engineer is a subset of
DevOps.
DevOps. And the DevOps engineer is a superset of cloud engineer. Got it. So as a DevOps engineer, we need to learn.
Cloud engineer is the ops side, but the dev side is also connected.
Yes. So as a DevOps engineer, we need to learn so many skills, right? When coming, instead of cloud engineer. So that's the area actually. So as a DevOps engineer, we need to learn so many tools, the life cycle, culture, all the things. Got it?
Yeah.
Yeah. And coming to culture, collaboration, okay. We continuous learning. That is, we need to learn new things quickly whenever new requirement are there. So that's all under the DevOps part actually. For example, nowadays DevOps engineers are continuously learning. Got it? Hi,
I see.
I'm audible, right?
Welcome back.
Yep. Okay. Some network issues. Yeah. So, yep. Now we are discussing the benefit of DevOps. Okay. One of the main benefit is faster time to market actually. Rapid development, testing and development result in quicker release cycle. When we are using the DevOps life cycle. Then the reliability, okay, increased reliability. Automating testing and deployment leads to more reliable software. The next one is improve collaboration, enhance communication and collaboration between teams. The dev part and the operation part. There is improved collaboration using DevOps principle.
Yes.
Yeah, and it's a type of engineering. Actually, DevOps is a engineering is approach to software development and IT operations that emphasize the collaboration, automation, and continuous improvement, like using the DevOps principles. So mostly organization can achieve faster and more reliable, efficient software delivery and enhancing their competitive in today's dynamic business landscape. That's why most corporates or even the startup companies are acquiring these types of DevOps lifecycle for delivering their newly softwares.
If they have the funding.
Yes. So these are the high level overview of the principles, culture, benefits, and all the things.
Right.
Any doubt or
No, I think
now
the only thing is when I create the AWS account and give my card, I just have to be careful how I use it so I don't get charges. That's all.
that I
Like
will
your
cover in the next section. Okay. Now in the next section, we are going to the AWS part actually. Starting from the cloud basics. So from next class, we need to having the account actually, AWS account, and we are going.
Is there a way you can close a AWS account? I don't think there's a way you can close it once you start it, right? All internet companies, once you create an account, it stays forever.
Yeah. You mean closing account, right?
Yeah, closing. I don't think you can close the AWS account.
We can deactivate the account actually.
Okay.
Yeah, there is the option to deactivate.
Okay.
So, yeah. So we can wind up today, right?
Sure, whatever is.
Yep. From the next section, we will go, starting from the cloud basics, okay?
So
Cloud
you want me
service.
to put in my credit card and have my AWS
I
login
think
ready?
in next section we need to discuss that. The creation of account and everything.
Okay, and then after that I'll do.
Yep, yep.
Okay.
Okay. Okay, then bye.
Okay, thank you. Have a good day.
Yep, yep, bye, bye.